Okay, big day. We are going to meet today for the first time this thing that is called the unit circle, and how in heaven's name it's related to sine and cosine. So this thing on the paper, that hopefully you have this template with you ready to write on it. I'm going to write off to the right here. I realize on your paper you're going to probably want to write down below because that's where your space is, but so I can kind of do everything at once without going back and forth, I'm going to write over here. So this is what you need to know. The equation of the unit circle is x squared plus y squared equals 1. So this circle on the paper, the reason that's the equation, since it's just x squared plus y squared, the origin is the center of the circle, and since x squared plus y squared equals r squared equals 1, so the radius, any radius we want to pick is 1. So now I want to explore a little, and you're going to have to trust me because I have drawn, and this right here would be your terminal, or your initial side, I'm sorry, for every one of these angles is right here, sort of your positive x-axis. And I have gone ahead and used my protractor to label a bunch of different angles. So like this one's 20, this one's 70, you can go around and see. And I'm not going to play with all of these, but you might want to play around in a second with them. And I want to focus on this 20 degrees. So I'm going to go ahead and call this theta. And what I have done here is we're going to look at this point because there's something interesting. I'll just call that point P going on. And so I have dropped from point P down to my initial side. I have dropped a segment that is perpendicular. So I would do that with a straight edge ideally. So this is a 90-degree angle. So just focusing on this for a minute, we'll get back to the fact that it's really a 20-degree angle. We'll explore something. So just a little review. The cosine of theta, if you recall, so ka toa, is the adjacent over the hypotenuse. So looking at this angle here that I am interested in right now, I'm going to go ahead and do a little bit of labeling. So we have this point here P that has an x and a y value, which we're going to figure that out here in a second. So with this segment that I've dropped here, hopefully you can relate to the fact really that this length here is really x, because if I'm trying to get to that point P, I'm going to go across x to this point, and then I'm going to travel up this much, which represents my y. So I'm just going to go ahead and label that guy y. Now, I'm also, because I care about theta in this case, going to label up my triangles. So the side across from the 90 is the hypotenuse. The side across opposite of the angle I care about is my opposite, and by process of elimination, this is my adjacent. So if I go ahead and start filling in the blanks up here then, my adjacent is x, and my hypotenuse, because I'm in the unit circle, is 1. So the cosine of theta is going to be x. So now, just to kind of complete this idea, let's look at sine also. The sine of theta, remember, so ka toa, is opposite over hypotenuse. So if I go back to my lovely labeled triangle, I see that my y is my opposite. So I have y over, and my hypotenuse is still 1. So the sine of theta is y. Well, interesting, because this is an x and this is a y. So let's go ahead and fire up our calculator, and in this case theta, because I've actually used a protractor, is actually 20 degrees. So let's fire up our calculator and let's see, like, what in the heck is the cosine of 20 and what is the sine of 20? Remember, we always want to have our calc in, the mode needs to be in degrees, so if for some reason someone else has borrowed it and changed it to radians, you want to make sure it's in degrees. So first I'm going to type in cosine, and I'm going to type in 20 and see what comes out. So as it turns out, the cosine of 20 is, we'll call it 0.94. And the sine of 20 is 0.34. So I'm going to come back here, and this point here then, technically, since this is my x value and my y value, should be, my cosine of theta is my x value, so that should be 0.94, and my sine of 20 is 0.34, so that should be my y value. Now, it's a little hard on my smartboard to see this, so I would suggest you actually look on your own paper and see, by counting these blocks, each one's worth 1, see if it appears, and it's not perfect obviously, that this p-value, the x value, could be 0.94. It should look relatively close. It won't be perfect. And then if you do your counting up for your y value, you should see that if you count up, it is approximately 0.34. So what we are doing here is discovering this amazing thing about the unit circle. And this is what it is. On the unit circle, it is a fact that the x coordinate is the cosine of theta. Now I could write more, but I want to try to be simple about it. It really, to be more complete, is the x coordinate where the terminal side of the angle crosses the unit circle. So this is a 20-degree angle, and this is where it crosses the unit circle. So the x value of that point is the cosine. And then the other thing then is that, just write and here, the y coordinate is sine of theta. This is big, okay? And to be more complete about this, I could say the y coordinate where the terminal side of the angle crosses the unit circle is the sine. So there's this graphing connection to actually what cosine is and what sine is. So if we were to put 30 degrees on here, the sine of 30, if you check it, it's a half, and you'll see on the graph, if you put in 30 degrees, that sure enough, the y value is 1/2. Now, I'm trying to get you to so you can understand where this is coming from, but in the end, you just need to know it. So let's talk about ways that you are going to remember this. X comes before Y in the alphabet. C comes before S. So that would be one way to remember it. So the x value is cosine, the y value is sine. When you even think of the word cosine, it kind of flows. So really, in the end, if I wanted to relabel these points up here, the point is really the cosine of theta, the sine of theta. Okay, if you learn this from this little thing here, then you're on your way to understanding a lot. So let's just do a couple examples. So say that you are given a point and you're told that the point is on the unit circle. And someone says to you, what's the sine of theta? Now you don't have to be getting worried about what theta is, because that's not what the question is. So you're just going to go ahead to what we just learned. We learned the x value is the cos of theta, the y value is the sine of theta. So the sine of theta, radical 3 over 2. The cos of theta, negative 1/2. So just remember, x, y, and then it just drops down. Cos theta, sine theta. It's pretty straightforward once you just kind of get it in your head. Okay, another example. Someone tells you what theta is. So you're told what this angle is in standard position in the unit circle, and you're asked to figure out what are the coordinates of the point. So you need to realize then, if theta is 72, then the coordinates of the point are cosine 72, sine 72. And if you just fire up your calculator, out should come something like, actually I'm going to check this because I don't like what I see on my paper. Okay, so the cosine of 72 is, we'll round to hundreds, 0.31, and the sine of 72 is 0.95. So I'll come back over here and write that. So the coordinates then would be 0.31 and 0.95. Easy, right? Okay. Next, what if someone asked you to figure out the sine of negative 450 and the cos of negative 450 without a calculator? So this is going to take you back to the last section, hopefully, and I'm going to not use a calculator because I'm going to try to figure this out. Now remember, when it's a negative angle, I'm going to go in a clockwise direction. So to go negative 450, so you just sort of have to start feeling like this. If I go this way, it's positive, and that's not what I want to do. Most of the angles we look at, we're going to be going in that direction. And the more you do, the more comfortable you'll be. So instead, I got to go the other direction. So basically, I'm not even going to draw the unit circle. I'm going to just kind of go like this and say, okie dokie, there's 360. But I'm not done because I got some more degrees. So the question really is, how many more do I have? So what is the difference between 450 and 360? And that difference is 90. So on my little ride that I'm on, I got to go another 90 degrees. So basically, I need to say to myself, on the unit circle, what is this point? If you remember, the radius of the unit circle is 1, so I know that this point on the unit circle then is going to be located at an x value of 0 and a y value of negative 1. So if I need to figure out what the sine and the cos are, then I just say, oh, that's no problem for me. The sine of negative 450 corresponds to my y value, which is negative 1. And the cosine of negative 450 corresponds to my x value, which is 0. And you can confirm that on your calculator. Okay, one more example. If there's some point 1/2 comma y, and it's on the unit circle, to figure out what y is, figure out what the sine of theta is, and what the cosine of theta is. So I'm going to go ahead and just sort of draw myself a little sketch. It's not going to be pretty, but it's going to help me think about this. And I want you to start thinking a little bit about this concept. If the cosine of theta corresponds to the x value, and the sine of theta corresponds to the y value, that does tell you a little bit about kind of where is cosine positive and where is cosine negative. Where is sine positive, where is sine negative. So when we think about x values, and I'll just go ahead and remind you of the quadrants here for a minute, you just sort of say to yourself, well, where is x positive? Well, x is positive over in this neck of the woods in quadrants 1 and 4. X is negative over here in quadrants 2 and 3. Okay, and you can do the same thing with sine. So I just want you to kind of start thinking about that, okay? I'm not going to get too involved with it, but you got to think about that a little bit. Okay, so if there's some point and it has an x value of 1/2 and a y value, which currently I don't know, if this would be my x value, it doesn't have to be perfect, then there is a y value there that could correspond, but in reality there's also a y value down here that would have that x value. So really there's an angle here that would get the job done and an angle here. But for the purposes of this, I'm just going to draw my little triangle there, and I'll bring it out here and blow it up a little bit. Okay, so I know because I'm in the unit circle my radius is 1. I know my x value is 1/2, and I don't know my y. So I need to figure out what my y is, and good old Pythagorean theorem is going to come to save the day. So I'm going to take 1/2 squared plus y squared equals 1 squared. So I get 1/4 plus y squared equals 1. So then y squared equals, I'm going to change that 1 to 4 over 4 for a minute, minus 1/4. Don't be afraid, these are fractions. So then y squared is equal to 4/4 minus 1/4 is 3/4. I'm going to square root this guy, which I'm going to get a positive and a negative. So this would be positive or negative radical 3 over the square root of 4, that gets free, is 2. Now why is there a positive or a negative? Well, in reality, there could be a positive y value when I'm up here in quadrant 1, and there's a negative y value when I'm down here in quadrant 4. So then this answers part A as far as what is my y value. So now my life is easier, because in order to figure out what the sine of theta is, now that I understand x, y, cs, the sine corresponds to my y value, so the sine of theta could be plus or minus radical 3 over 2. What is the cos of theta? It corresponds to my x value. Now remember, we were given this x value, and so there's only one, and that would be 1/2. So a little bit more application of this concept here. I'm going to show you a U-try if you want to give this a try on your own. So you might want to pause the video and write this down and just give it a try. Similar problem, just different fraction basically. And then after you do that, you can restart the video and come along and take a look at my solution, which is right here, to see if you're starting to feel this unit circle stuff. And then you want to go to mathexcelforschool.com and do the homework. And you should be smiling because you've met the unit circle. And this is kind of a big part of sort of the trigonometry aspect of Algebra Trig.